Last lecture, we take the example based on the laws of logarithm. Today's lecture, we start very important topic that is of logarithm, that is change of base rule. So, log a to the base b is equal to log a to the base x, log b to the base x. X is belongs to real number. For simplification, you have to take any base, but be clear about that these base must be same. Or we have to convert log a to the base b by interchanging position. That means 1 upon log b to the base a. I repeat again. Change of base rule. Log a to the base b is equal to log a to the base x upon log b to the base x, or 1 upon log b to the base a. We can interchange the number and base. Now we have to take the example based on change of base rule one by one. Change of base rule of logarithm. First, log a to the base b is equal to 1 upon log b to the base a. Suppose I want to take the example for this log 5 to the base 3. I want to interchange this number. So obviously we have to apply a is equal to 5, b is equal to 3. That is equal to, we have to put this value in the expression. We get 1 upon log 3 to the base 5. Second change of base rule is defined. Log a to the base b is equal to log a to the base e, log b to the base e, or any base you want to simplify. Suppose I take the base is e. So I want to convert log 7 to the base 3 in numerator and denominator form. So I use these change of base rule. I put the value of a is equal to 7, value of b is equal to 3. So in this right hand side of expression, we derive log 7 to the base e, log 3 to the base e. Change of base rule introduce very important step in reverse way also. Suppose log x to the base b upon log a to the base b is equal to log x to the base a. I repeat again. In the change of base rule, we shift RHS equal to LHS. Also LHS equal to RHS. Is what if numerator log x to the base b upon log a to the base b is equal to log x upon a. We better understand by taking the example based on that expression. So we have log 16 to the base any and log 2 to the base e. If not base is given, we consider the base is e. So putting this expression, x is equal to 16, a is equal to 2 and b is e. So we can convert log 16 to the base 2. Better understand, we use this format. These log x to the base b, here x goes to this side of numerator, b goes to denominator, and c is any base. You have to simplify. We take the simple example to evaluate the value of, suppose log 9 to the base 7. So I get the e is base. So log 9 to the base e and log 7 to the base e. We know that log have base e is denoted by ln. So 9 ln 9 upon ln 7. These can easily calculated by calculator, that is ln 9 gives the value 2.1972245 and ln 7 gives the value 1.9459. I explain again. Log 9 to the base 7, we can simplify log 9 to the base e upon log 7 to the base e. We know that log have the base e is denoted by ln. So ln of 9 upon ln of 7. It is easily calculated by the calculator. 2.197245773 1.9459101490. We take the simple example by change of base rule, that is evaluate 1 upon log 2 to the base 8 plus 1 upon log 2 to the base 4. We have by change of base rule 1 upon log b to the base a is equal to log a upon a to the base b. So we take the first term and second term and addition is there. So first term using these change of base rule interchange. The base goes to number, number goes to base, that is log of 8 to the base 2 plus log of 4 to the base 2. Here also same rule is applicable. But if base is same and log term is in addition, we have the laws of logarithm, that is log m plus log n is equal to log m into n. So what is the value of m is compared to this step? M is equal to 8, n is equal to 4. So we have 8 into 4, that is obviously 32, and 2 base remain as the same. But 2 and 32 also have relation. We know that 2 raised to 5 is equal to 32. So I put instead of 32 2 raised to 5. So I derive log 2 raised to 5 to the base 2. We have the basic power function law of logarithm, that is log m raised to n is n log of m. So we put m is equal to 2, n is equal to 5. So we derive the 5 log 2 to the base 2. These 5 index number goes to left hand side of logarithm. So here we take 5 log 2 to the base 2. But laws of logarithm gives log a to the base a is equal to 1. That means log 2 to the base 2 is equal to 1. So 5 into 1 gives the final value is 5. So we have to derive the value of 1 upon log 2 to the base 8 plus 1 upon log 2 to the base 4 is equal to 5. I explain this type of example again. They given that evaluate 1 upon log 2 to the base 8 plus 1 upon log 2 to the base 4. In this example, we observe that both the terms have the same number in denominator but base is different. So we can apply change of base rule. 1 upon log b to the base a can interchange log a to the base b. Hence, we get each term completely simplified by change of base rule. So it is goes to interchange. So we derive log 8 to the base 2 plus log 4 to the base 2. So we have log m plus log n is equal to log m into n. So is equal to log 32 to the base 2. How we derive the 32? We know that the 8 into 4 gives the value 32. We have to evaluate, means we have to derive the final answer from the above expression. We know that 2 raised to 5 is equal to 32. So I put the 32 instead of the terms. We have to put 2 raised to 5. So log 2 raised to 5 to the base 2. We observe that 2 and 2 means number and base is same. So we have log m raised to n is equal to log m. So we convert this 5 in the left hand side of logarithm. We derive 5 log 2 to the base 2. We know that log a to the base a is always 1. That means log 2 to the base 2 gives the value 1. So 5 into 1 is equal to 5. Now we have better understand the change of base rule by above examples. But now we have to take the example based on laws of logarithm as well as law of indices. Let us start from some example based on this topic. We have evaluate log 16 to the base 8. Consider log 16 to the base 8 is equal to x. If any value we don't know, we have to put the x. We have log y to the base a is equal to x. It convert in exponential form or power function a raised to x equal to y. So I can convert 2 raised to 3 raised to x because 8 is the expansion of 2 raised to 3. 16 is also expansion of 2 raised to 4. We compare because the equal sign is there. We know that a raised to m into n is a raised to mn. So that's why 2 raised to 3x is in an index is equal to 2 raised to 4. So we derive 2 raised to 3x is equal to 2 raised to 4. We know that if base are same, then index are equal. Therefore, 3x is equal to 4. Therefore, x is equal to 4 upon 3. So, we have to now convert the following into single logarithm. That's most probably we have to use n log of m is there. 2 log 5 plus 3 log 4 minus 4 log 2 is what we have. N log m is equal to log m raised to n. So we have 2 log 5 plus 3 log 4 minus 4 log 2. Use m raised to n concept. So 2 goes to 5 raised to 2, 3 goes to 4 raised to 3 and 4 goes to 2 raised to 4. So here we have to mention that here plus symbol is there. So we can easily solve log 25 plus log 64 plus log 16 is log m plus log n is equal to log plus log r is equal to log m and r. I take multiplication of these number 25 64 into 16, it is exactly 256 bracket 00 bracket square. How we derive? We know that 160 have the square bracket square. So we convert the 3 terms logarithm into single logarithm term. Be clear that here I give the minus, we solve in a plus format, and in a minus format also we can easily solve this example. We take this exam in a next lecture in a form of plus sign.